And good morning, everybody, and welcome to this webinar. My name is Piero Valmassoi, and I'm a project manager at Greenovate Europe, a non-for-profit network dedicated to sustainable innovation. I'm very pleased to welcome you to this first jointly organized webinar by 3 EU-funded projects: FUELPHORIA, BUTTERFLY, and POSEIDON. These 3 projects started in the second half of 2023, and were funded under the same Horizon Europe call, which aims at the demonstration of complete value chains for advanced biofuel and non-biological renewable fuel production. And this subject is also reflected in the title of our webinar, as you can see in my first introductory slide, which is Innovative, Sustainable and Complete Value Chains for Advanced Biofuels and Non-Biological Renewable Fuel Production. And to start diving deep into the webinar, let's go together through the agenda of today. In the first part, as you can see, a representative from the 3 projects will present objectives, methodologies, and case studies of their respective projects. And we also provide an overview of the activities that were put in place in the first year. And after this 3 introductory presentation, we will pass to the second section of the webinar, where a project representative will come back to our virtual stage to discuss drivers and barriers to the value chains that they are establishing and testing, and the challenges to the upscale of these value chains. They will also exchange views with a representative of the European Commission on the EU-level support to these value chains and the production and the project contribution to EU-level policy objectives in the field of renewable fuels and biofuels. Here is the complete list of speakers of today. We have Galina Skorikova from TNO Netherlands, the Dutch Organization for Applied Scientific Research, which is the organization who coordinates the Butterfly project. We have Kostis Atsonios from CERT, the Greek Center of Research and Technology, scientific coordinator of the FUELPHORIA project. The third presentation will be provided by Paul Haering of the Steinbeis Europa Centrum, the consortium member in charge of communication and dissemination in the POSEIDON project. And for the panel discussion, Galina and Kostis will be joined by Katja Haas-Santo of the Karlsruhe Institute of Technology, one of the consortium member of the POSEIDON project, and Maria Georgiadou, a senior expert in the Directorate General of Research and Innovation at the European Commission. We are about to get started, but before we really kick off the presentation, I would like to remind you that the webinar is being recorded, and both the recording and the slide will be circulated to all participants. Attendees are in listen-only mode, but you have the possibility of sending your question via the Q&A box that you see down below. If your question is specifically directed to one of the speakers, I'd ask you to please mention it in your question. We will take them both at the end of each project presentation and also at the end of the panel discussion. So, without further hesitation, I will stop sharing my screen. And I welcome to the virtual stage Galina Skorikova that will present the Butterfly project, which aims at the production of renewable and recycled carbon, the methyl ether, and the synthetic natural gas from waste and residual feedstock, targeting the steel industry and heavy transportation. Galina holds a Master of Science in Chemical Engineering from Gubkin Russian State University of Oil and Gas, and a PhD in Physical Chemistry from University of Saarland. She works at TNO as a technical consultant and a researcher towards a CO2 neutral industry. And in the past 3 years, she has been actively involved in process design for CO2 utilization into synthetic fuels and chemical using industrial off gases and residual biomass. Her research focuses on process intensification using a separation enhancement, conceptual design, and techno-economic analysis and use case studies. So I will stop here for now, and Galina, the floor is yours.
Thank you, Piero. That is very convenient when someone already introduced you. So I will share the screen. Please let me know that you will see the slides.
Yes.
Okay, great. So good morning, everyone. Today I would like to present the BUTTERFLY project. The title of that basically represents the renewable DME and synthetic natural gas production from feedstocks of both biological and non-biological origin. So let's jump directly into the objectives. The main objectives of BUTTERFLY are flexible production of sustainable DME and synthetic natural gas from both different groups of feedstocks, and the project aims to demonstrate it at the pilot level. At the pilot level, we will demonstrate the flexible and efficient, low-cost process to produce both components using indirect gasification technology and sorption-enhanced DME synthesis, followed by methanation. So this project is a Horizon Europe project, which started in July last year. It will last for 3.5 years. So obviously it includes partners from different countries of Europe. So you can see the map. We have North Europe involved, South Europe, East Europe, and West Europe. So it's quite diverse. It has research organizations, and it also has plenty of industrial partners. So that gives us quite a diverse team. First, due to the time constraint, I would like to jump a little bit over the main points of the concept and also share with you the activities that we have been busy with in the past year. So the lineup of the process you can see in the slide. It starts with the feedstock pretreatment, both biological and non-biological, as I've already mentioned, which goes to indirect gasification, followed up by syngas cleaning, and co-production of methane in the methanation section or DME in the sorption-enhanced DME synthesis section. You can also notice CO2 capture in the flow sheet because we have flue gas in the indirect gasifier, and it can be captured and reused when green hydrogen is abundant. You can also notice that this hydrogen comes from the electrolyzer, so we also consider electrolysis in our lineup. And of course, the side product of the electrolyzer is typically oxygen, which we also propose to reuse in the indirect gasification for oxygen blown gasification. In this case, we can avoid nitrogen in the flue gas and go directly to pure CO2. That would simplify the process quite a lot. Also, we are considering to use electricity when it's abundant for electrified gasifier mode. And I will go through the different points of this lineup and explain why we are convinced that this is a very flexible concept. So first of all, the highlights, why we are ambitious to go to TRL 7. We think we can do it because we already have existing pilots. For example, Gaia plant, which is located in France, it belongs to ENGIE, and it's a semi-industrial R&D platform, which includes the gasifier and the methanation. And the SEDMA sorption-enhanced DME synthesis pilot that you can see in the middle is at the moment located in Patent, the premises of TNO in the Netherlands, but it will be moved to France to be connected to the Gaia platform. You can also see the Torosh plant. We have visited it recently. So basically, this is a feedstock pretreatment, which is also already at high TRL. The levels of flexibility. So conceptually, we have 3 levels of flexibility in this value chain, starting from the feedstock supply. we believe that our concept is primarily focused on the decentralized production, meaning that we would like to facilitate the hubs for circularities and local for local. We want to source feedstock from the certain region and utilize the products also in the region or in the neighboring region, but within 100 kilometers away. And depending on the region, of course, where geographically it is located, of course, the sources of biomass can be different. It can be lignocellulosic, it can be industrial waste, or it can be upgraded wet organic residues. So depending on that, we are also convinced that different modes of gasifications could be also more suitable. So in this case, we will also select which mode is the most beneficial. And also the next level of flexibility comes in the core process, where we can tune the ratio between renewable DME production and synthetic natural gas production. And it will highly depend on, first, availability of green electricity to produce hydrogen, and second, on the market pool. And the third level of flexibility is an application. So we know that DME can be a replacement for LPG in off-grid energy supply. We know that synthetic natural gas can be used in shipping or in heavy-duty transport, or also in residential, of course, if it's injected in the pipeline. And both of these components can be used in steel industry. So depending what is around your plant, the application could be also different. So a few words about sorption-enhanced dimethyl ether synthesis, because probably you're already familiar with the gasification. Sorption-enhanced DME synthesis is an innovative TNO patented technology which produces renewable DME from CO2 or from CO2-CO mixture in one reactor, so in the single reactor, single pass. Of course, we use several reactors because it's a cyclic process. You can see now in the slide, a little bit maybe complicated, but each reactor goes through this several processes of pressure swing adsorption. And in the bottom, you can see the reaction that happens. So CO2 reacts to hydrogen on the traditional copper zinc catalyst for methanol production. Then we produce methanol and a lot of water. So in order to shift equilibrium to the product side, we adsorb water on the LTA, zeolite type, and eventually we produce DME, which also involves quite some byproduct water production, which is immediately adsorbed as well. So due to the equilibrium shift, the selectivity is very high, and the yield of DME could be much above 75% per single pass. So here a little bit more science. So to say, how do we choose, how we tune between SNG and renewable DME production? So we already know that the ratio between hydrogen and carbon, which is also known as M module, is determining how much product you will form. So DME requires M module of 2, and methane requires a module of 3, meaning that it requires more hydrogen. So depending on the hydrogen availability, we can produce more or less SNG, and also depending on the market demand, as I've said earlier. So here also a little bit of visualization of that. Imagine that we have electrolyzer, and there is a green electricity that is available at the moment. We can produce hydrogen and we can add it to the system to maximize carbon efficiency. So you can see for both products of DME and SNG maximization, the carbon efficiency increases with the addition of hydrogen, and it can potentially reach 98% when we also utilize CO2 from the flue gas, as I mentioned earlier. So potentially it's a very high efficiency technology if green hydrogen is available. Unfortunately, we are all aware that there is excess carbon in biomass, so you either capture and store it, or you use green hydrogen to utilize it. So here a little bit nuances on DME yield, how we can basically tune between methanation and DME formation is more DME is produced when the bed is dry. So it's very sensitive to the partial pressure of water. So when partial pressure of water is close to zero, we produce a very high, close to 100% of DME. But once it increases and the bed becomes wet, then we produce much less DME. So by playing with the regeneration of the bed, if we make it more dry or less dry, we can tune how much DME we produce and how much CO2 just passes through and go to the methanizer instead. So some few details on the work package 2, work package 4, and work package 5. Work package 2 is dedicated for technology de-risking. So, for example, in Patton, we already have 2 laboratories. One includes the SEDMAS pilot, and the second laboratory includes indirect gasification lab together with the gas cleaning. So our ambition is to connect these 2 labs to demonstrate the technology lineup at TRL 5 and to de-risk all possible complications that we could face when we move pilot to Gaia platform. So we're already building this connection. But unfortunately, some activities were paused. I will mention it later. Our focus feedstocks are agricultural residues, auto-shredded residues, and black pellets provided by Torwash. So it's a wet organic fraction. Here, I would like to mention that we have been busy with testing different feedstocks already to screen what are the optimal conditions for gasification, what is expected M module of the syngas. You can see in the slide that we have tested already waste wood, olive pomace, and also RDF. The composition is in the graph. So you can see that the variation between CO, CO2 is quite significant, and also presence of methane, ethane, and higher components is obvious. So we need to find the strategy of how to properly select the feedstock in order that we utilize all available products. The feedstocks to be tested next would be waste wood, cereal straw, flax, and black pellets. Work package 5 is focused on the market identification and technology exploitation. So here we have set up a framework, and we are curious to learn what would be the most beneficial locations for our first of the kind plants. So we want to know what type of feedstock origin, how it is sourced, what would be the best plant size based on the feedstock availability, who would license this technology, how far do we need to distribute their products, and by what means of transport, and who will eventually use it. So what should be the product specification and quality. So we have been exploring this one, and we started with some input from work package 4, which is focused on assessing the optimization and digitalization of the value chain. So we have already done the first level availability assessment. We defined the countries, the target countries. So you can see Finland, Poland, France, and Italy. And we defined the criteria for the feedstock, and obviously it's very diverse. Finland is very rich in wood waste. South of Italy could benefit from utilization of olive pomace or prunings. Randstad of the Netherlands is obviously very strong in municipal solid waste. Poland in auto-shredded residues because of the car manufacturing, and France is very diverse. So we are working closely with industrial partners to define the best location and to optimize the value chain. So the ambition of the project, So after we have demonstrated the technology at TRL7 in 2027, we would like to upscale it to 32 megawatts feedstock inlet in 2030, and that will allow us in 2035 to build already 5 plants of typically 4 megawatt scale. So it's a relatively medium scale, not that large, but decentralized. And the final ambition by 2050 would be to build 250 small to medium scale plants for renewable DME and SNG production. So due to the time constraints, I need to finish here, but I would like to welcome you to visit our website because there are plenty of information on the project. Unfortunately, it has been on hold for a couple of months due to the partner change and also due to some uncertainties when Sedmes plant could be moved to France to be connected to Gaia. But we are very optimistic that in January we will restart it again and realize our ambition. So thank you very much. I think that's all from my side.
Thank you very much, Galina. And for sure, we will have time to further elaborate some of the aspects of the Butterfly project in our panel discussion later in this webinar. And I don't see any questions for you for the time being, and I encourage the audience to just drop your questions if you'd like in the Q&A down below. And in the meantime, I would like to welcome on stage the next speaker of today, who is Kostis Atsonios, the coordinator of the FUELPHORIA project. Welcome, Kostis. The FUELPHORIA project, in a few words, aims at demonstrating that different types of feedstock, CO2, digestate, municipal biowaste, can be converted into a series of renewable gas and liquid fuels suitable for different applications such as transport and power production. A brief introduction of Kostis, who is a PhD mechanical engineer from the National Technical University of Athens and a research associate at CERT since 2010. He specializes in the study of advanced energy systems and processes, mainly related to low carbon emissions. He has experience in process modeling and energy system design and performing thermodynamic calculation on various processes, such as thermal plants, biorefineries, synthetic fuels production, energy storage concepts, low carbon technologies, and at industrial plants. He is the coordinator of the Horizon Europe project FUELPHORIA, and he was also the coordinator of the recently ended Biosphere project, whose topic was very much connected to what we are talking about now. And without further hesitation, I will give him the floor. And
thank you very much, Pierre, for the introduction, and welcome and good morning to everyone. I start my presentation of a project that deals with the acceleration of sustainable production of advanced biofuels and renewable fuel with no biological origins, dealing with the overall value chain from the feedstock until the end use. Starting with two statements from that also consists the driver of that project. One from the REPowerEU plant, where there is the admission that it's very necessary to scale up renewables to achieve the electrifications and replace fossil-based heat and fuel in industry, buildings, and in the transport sector. And it's spotifying the necessity to work on new renewables sources and to perform and in order to meet the target of that the EU has been set. And the second coming from the recently revised Renewable Energy Directive, the third version, where it suggests that 5.5% share of advanced biofuels and renewable fuels of non-biological origins is set as a mandate in final consumption for all energy supplied to transport. with 1% of this to be from the RFNBO with a minimum share, and concerning the maritime transport, indicatively, the goal is set at least 1.5% by 2030. So, FUELPHORIA is a project that aims to establish sustainable, competitive, and secure value chains to advance biofuels and RFNBOs. A few aspects about the project. The project, like the other two that we co-hosted, co-organized these webinars, is now we are running at the beginning of the second year. It started last October, and its duration is 48 months. The overall budget is of something greater than 11 million euros, where the EU contribution to be at around 9.6 million euros. As Piero introduced in his introduction, says that the coordination is central CERT from Greece. The beneficiaries in this consortium are 22, and we have also 3 affiliated entities as a linked third party and 1 associated partner from the EU. And like the other 2 projects, this project was funded under the topic of demonstration of complete value chains for advanced biofuels and non-biological renewable fuel production. Now coming to the key objectives of the project that FUELPHORIA tries to address. The first is to demonstrate at TRL7 at demo scale robust and cost-effective technological solutions for the production of advanced biofuels and renewable fuels with no biological origin, using feedstock, sustainable and renewable energy. The second is to set up a portfolio of sustainable, secure and robust value chains that are completed, again for the production of both biofuels and renewable fuels with no biological origin, and focusing not only on a specific part but on the entire cycle from feedstock to the end use. The third key objective is the promotion of the exploitation of advanced biofuels and RFNBOs, identifying the barriers that should be overcome in value chains, not only at EU level but also in Africa. And since also there is a very strong connection with Africa, because we have also 2 partners from that continent. The fourth objective is to promote the exploitation of advanced biofuels and RFNBOs through policy recommendations at the European level. And the fifth key objective is the promotion and exploitation of advanced biofuels and renewable fuels, using new business and marketing concepts in the 2 continents mentioned, Europe and Africa. Now talking about the concept of the project and the main dimensions. The first pillar, which is the sustainable feedstock, and the definition of this. We are considering various concepts, including that where the feedstock is biogenic residues and waste, biogenic CO2 or CO2 coming from bio-based industries, and renewable fuels, because it's important so that the final fuels to consider as renewable. The second pillar is the establishment of this type of competitive technologies that are making progress beyond the state of the art. These technologies consist interesting pathways which are from the field of biochemistry, thermochemical, biochemical, chemical, photobiological, electrochemical, and of course combination of them into the different value chains that we are investigating. More information about that process I will talk later. The third pillar is the production of high quality fuels, which are the end products. These fuels will aim to meet the quality specifications as defined for their applications, not only in the transport sector, but also in the power production sector as well. And the fourth main pillar that also is a strong connection with all of them is the exploitation that we aim to foster, and in that case the main objective is to consist of a building block of European actions to achieve improved citizens' perception on waste as a local resource and enable sustainable choice and acceptance of advanced biofuels. So a few words regarding the key interventions that are connected with these four main pillars. Is the first aspect is that this concept is realized at 4 demos that are now building, and we aim to optimize their operation. We give a special focus on the value chain approach in order to improve and optimize the overall concept that the value chain starting from the feedstock to the end use. Very important attention, a lot of attention is paid also on the environmental aspect through the LCA lifecycle assessment tools, the policy transformation, and the regulatory framework around in the field of advanced biofuels and renewable fuels, the new business and marketing concept, and as previously mentioned, the liaison between the two continents, Europe and Africa. These slides we give a brief an overview of the 4 demos where these key technologies and the new value chains are investigating in FUELPHORIA. I will talk more in details for each demo in a while. As you can see, the feedstock that is the suppliers of the sustainable feedstock is either biogas plants, winery, or waste treatment plant, providing with biogenic CO2 or digestate, and or organic urban waste, organic fraction of municipal solid waste. The final product is a portfolio of different fuels that are expected to play a very critical role in energy transition in the next years and decades, namely paraffinic fuels that are aimed to replace aviation and marine fossil-derived fuels, biodiesel, synthetic natural gas or synthetic methane, ethanol, and methanol. And the end-use applications are found either either for aviation and maritime, road transportation, gas-fired power plants, and island and power generation at isolated systems or island energy systems. Now, more information and more about an insight on these 4 very interesting demos, starting from demo 1. Demo 1, the main activities are carrying out in Belgium, where CO2 coming from a biogas upgrading in Antwerp is the feedstock for the production of the final fuels, which are paraffinic fuels and biodiesel. This CO2 is transformed into acetate into a mobile gas fermentation unit that will be installed in a few months at Aquafin's wastewater treatment plant in Antwerp. The produced acetate will be then the substrate for the production of microbial oil or triglycerides using oleaginous yeast in a liquid fermentation unit. The lipids will be recovered and isolated through a specific downstream processing train, and these oils will be used either as a feedstock in a hydrotreatment and fractionation unit at Czech Republic at Orlen, Orlen Unique facilities for the production of diesel-like and jet fuel-like paraffinic fuels, and part of this will be the feedstock for the production of biodiesel through esterification at Verge facilities in Greece. In these slides also we see the location of the wastewater treatment plant, where in 5 or 6 months the mobile gas fermentation unit from BEP that you can see in the right side will be installed and coupled with the biogenic CO2 coming from the biogas upgrading unit. The second demo is located in Spain. This demo deals with the valorization of CO2 coming from a fermentation process in a winery at Somontano in Spain, owned by Viñas del Vero company, winemaking company. This CO2, which is in a quite high concentration in the off gas from the fermentation process, is the feedstock for the production of synthetic methane. CO2 is treated and purified, and it's hydrogenated using hydrogen coming from a water electrolysis unit that is powered by PV photovoltaic field that is also installed at the Viñas del Vero premises in Spain. The technology that is employed is a catalytic reactor, aiming to with a feature to maximize the production of methane. In this demo, the leading the charge of the overall coordination of these demo activities is Circe, and also University from Rovia University is also responsible for the development of the methanator reactor. The third demo is located in northern Greece, in Thessaloniki. Also, like the first one, also deals with the valorization of CO2 coming from a biogas plant, but as a feedstock, not only use CO2, but also digestate from the biogas plant in order to cultivate and produce algae, microalgae, using high rate ponds. And this algae, after cultivation, are harvested and the lipids is extracted, and this lipid is sent to Verge facilities for the esterification and the production of biodiesel. As said, the location is in the biogas in Thessaloniki at the biogas Lagadas, the biogas unit of Lagada. And the fourth demo is the valorization of urban biowaste from a waste management plant using a high efficient and improved technology for the hydrolysis and saccharification and fermentation of this feedstock in the production of bioethanol. This concept aims on the minimization of the waste effluent streams, where the remaining solids, which mainly consist of vinasse, is used as a feedstock for anaerobic digestion and production of biogas, biomethane, and digestate. And the CO2 coming from the fermentation is hydrogenated in a catalytic reactor for the production of light alcohols by methanol and ethanol. The location and the main demo activities are in Perseo facilities in Valencia, and Sisica facilities, the second branch for the production of synthetic light alcohols in Madrid. And the key technologies that are found in this demo is the bioethanol reactor that is able to valorize and use sugars coming from urban biowaste, and the ethanol and methanol synthesis unit using advanced catalyst. Now finishing my presentation, I'm showing all the partners that consist this very interesting consortium. You can see that there we have a very good coverage from different countries along Europe, from the northern and southern part as well, and also we have the participation of the university, the Technical University of Mombasa from Africa, and together with the University College of London, they are working and involving on the relevant activities for the liaison between Europe and Africa and the exploitation and the investigation of replication studies at these African countries. Thank you for your attention. For more information about the project, you can use our communication channels like the website, our account in Twitter and LinkedIn. And thanks again. I'm happy to hear if you have any questions to answer.
Thank you very much, Kostis, for this very insightful presentation. I see that there are still no questions in the question and answer box. So again, I encourage the audience to feel free to ask any question you would like. And I will move on to the next project presentation. And I welcome on stage Paul Haering of the Steinbeis Europa Centrum. His presentation today will be about the Poseidon project, which aims at facilitating the use of e-methanol in shipping by demonstrating innovative solutions along the renewable fuel value chain. Paul holds a master in renewable energy and energy efficiency from the University of Kassel in Germany, and he has been working as a project manager as a Steinbeis Europa Centrum since 2019. He's an expert in the field of energy management, hydrogen, and innovative energy systems. In EU projects, he oversees communication, exploitation activities, and helps project partners in finding exploitation routes for their innovation. I will give you the floor, Paul. Please, the floor is yours.
Thanks, thanks, Piero, for this nice introduction. It's my pleasure today to present to you this Poseidon project, and we're also really happy to be invited to this first webinar with our two sister projects. So this is the agenda for my presentation. So very short presentation. First, I want to present you key project facts. Then I will deep dive into the Poseidon value chain from feedstock to end use. And my last slide will be about preliminary results we were able to produce in the first year of the project. So first, key project facts. So Poseidon is a short name of the longer project name, which stands for propulsion of ships with e-methanol in favor of the decarbonization of naval transport. So what we plan to do in our project is to accelerate the transition to alternative fuels, particularly with e-methanol. And I will show you after what are our project activities. So the project is coordinated by the European Institute for Energy Research located in Karlsruhe, Germany. So unfortunately, our coordinator was not able to make it today, but I'm happy to represent him. We have a total project budget of 12.6 million euros and total EU funding of about 10 million. So we also have some funding from Switzerland, since we have partners, WinGD, Swiss partner in our project consortium. Additional key facts about our project. So it lasts 4 years. It started in September last year and runs until August 27. We have 19 partners, mostly from Western European countries, but we also have one partner from Sweden and several from Greece. And a specificity of our project is that we have two pilot sites, the one located in Valencia in Spain and the other one in Thessaloniki in Greece. So I just want to highlight our project partners because their contribution are quite relevant for our projects. So we have a diverse set of partners. We have industrial partners, so like the French energy company EDF. We have the innovative German startup Icodos. We have a shipping company Fincantieri. We have two engine manufacturers, Isota Fascini Motori and WinGD. We also have a wastewater treatment operator in Spain, Global Onion, and a lime producer in Thessaloniki or in Greece, Kao Hellas. We also have two research partners from Germany, the Karlsruhe Institute for Technology and IFER, two from Greece, University Thessaloniki and CERT, and an Italian partner, which is STEMS, located in Napoli. As I said, we have two case studies in Valencia and Thessaloniki. So we also have the two local ports on board, Port Valencia and Port Thessaloniki. And the consortium is completed by two business support organizations, so Steinbeis and RINA, a biomass association, Avebium, and you also have a public agency in the name of the Swedish Maritime Administration. So our goals, goal is quite obvious. We want to try to implement the value chain we are investigating in the ports of Valencia and Thessaloniki. And for this, we have several objectives. So the first objective is quite technical. We would like to build an innovative methanol prototype plant, which is based on a new concept and which is highly performant to be able to produce a lot of methanol. But an important aspect also of our project is that we would like to work with stakeholders of the value chain. This is why we want to initiate a practice, so a group of people that gather and provide feedback to the project team. Another objective is that we would like to assess impacts of our value chain and benchmark all of our solution with other solutions available on the market, probably also other solutions that are developed by our sister projects. And all of these results will feed in local roadmaps that will outline the steps to be taken to implement the value chains in Valencia and Thessaloniki, but also at other locations in Europe, because we believe that our concept can be replicated in other ports or in other hubs. And last but not least, this is also my job today. We want to promote the projects. We want to connect with our stakeholders, and we want to help renewable fuels becoming a common fuels in the EU market and beyond. So we'll next move to our second chapter, which is about the POSEIDON value chain. So here you have a very easy representation of our value chain consisting of 3 blocks. So on the left, you have the feedstock we use to produce methanol. So it's mainly CO2, which can be biogenic or industrial. We also use in electricity, renewable electricity, and hydrogen. Then in the middle, we have our production plant, the methanol pilot plant produced by, or designed by Icodos, sorry. And then we plan to use the e-methanol in engines, vessel engines, so 2-stroke engine, 4-stroke engine, and in a pilot boat. So in the next slide, I will show you a bit what are these different bricks and how we would like to investigate different case studies. So starting with the feedstock. So we have 2 case studies in our project, as I told before, the port of Valencia and Thessaloniki. And there are, let's say, some differences between the case studies. So the first case study in Spain focuses on biogenic CO2. So in Valencia, we have our waste treatment plant operator, Global Onion, that operates different plants and which also produce biogenic CO2. And we would like to see how this biogenic CO2 could be converted to methanol, and also to better understand how many ships could be supplied with the produced e-methanol. So our first assessment shows that we would probably be able to power 3 tugboats with the produced methanol, but still these are some first estimations that need to be confirmed. Then we have our second case study in Thessaloniki. And in Thessaloniki, we have our lime producer, Kao Hellas, which is a bit further away from the port. I think it's located 10 kilometers away from the port, which has some industrial CO2 being emitted from limestone calcification. And here also we would like to better understand how this industrial process CO2 can be used to be transformed into methanol. And we also believe that probably since biogenic CO2 is a limited resources, we will need to use industrial CO2 as a transition pathway until end of biogenic CO2 is available. So that you understand also, it's in our project, we won't have a demonstration located directly in our use case city. What we plan to do is to develop a prototype, which I will show you on the next slide, and then to test this prototype in a test platform. But what we will definitely do is we will try to replicate the exact same condition of Valencia and Thessaloniki when we'll do some tests. So I want to highlight the methanol prototype that will be built in our project. So here you have pictures of the TUEL5 proof of concept plant that is already constructed and located at the KIT in Karlsruhe, Germany. This is pictures of our kickoff meeting. And building on this proof of concept plant designed by the KIT, our German startup ICODOS will build a bigger TUEL7 plant, which will be able to produce, if I'm correct, more than 700 liters a day of methanol. Just for you to imagine, this is a 50-liter plant, and the plant we will build will be much bigger in size than the few containers you see here. And what we plan to do with this plant is to test it, and it will be tested by EDF R&D at a test site close to Paris called EDF Lab Les Renardiers. And what we will do there is create a platform that will be able to host our e-methanol pilot plant. So we will have some gas supplies on the left. You'll also have an e-methanol storage tank on the right. And the idea, easy idea, but more difficult in practice, is just to plug the methanol plant in the middle and do some tests. And let's say the objective of the test are twofold. We would like first to do some durability testing to be able to see how far we can go with the plant, and if the plant is also able to withstand, let's say, the test conditions that we will perform, and also would like to see how she will behave given the different gas composition we will test. And another objective of the test are to produce enough methanol to do some engine tests. So this is next slide. So speaking of engine, we have VinGD and EFM in our consortium, so specialists of 2-stroke and 4-stroke engines. So they will test the produced methanol in their labs. And we also plan to use the produced methanol in a pilot boat in Sweden. And complementary to these activities, we'll also have research partners that will develop models to extrapolate the engine test results to multi-cylinder engines. So we will be then able to see if the fuels we're producing with our new technologies is compatible or let's say meet the standards for these types of engines and ships. And also what I forget maybe to highlight before when speaking about the plant of prototype plant of ICODOS, it also relies on an innovative concept combining CO2 capture and methanol synthesis. This highly performant plant allows to reduce OPEX and CAPEX, and we hope that in the future this plant will be the in EU and help to produce renewable fuels for the EU domestic market. So this will be my last slide. Just want to get some of the results we already produced in the first year of the project. So I apologize to project partners that maybe do not feel represented in this slide. I know that we have a lot of other activities going on, but this is just Some results I think important to highlight. So the first one, starting with the left, is the e-methanol value chain. So maybe it does not look super complicated as a task, but still it took us a lot of time to define the boundaries of our value chain, to determine which technology we will investigate in our projects. And this 7 months activity, which started at the very beginning of the project, was quite important to set a common vision in the consortium so that everyone in the following activities can reuse these results. And we also hope that results that we started in the project, that is, let's say, a living results, will help to design new standards and regulation for having interoperable e-methanol technologies in EU. The second result in the middle is about demonstration. So as I told you, we want to build a prototype plant and also want to build a test platform. So we have already reached some significant results. So regarding the pilot plant of ICODOS, so we are nearing the completion of the detailed engineering studies. This means that the plant or the building of the plant can start next year. So this is really a nice result. And also we have nice results to share about the test platform. So for the test platform, we reached the end of the basic engineering studies, and now we're entering the detailed engineering phase. So this is an important milestone in our projects to be able to produce fuel that will be afterwards be used by our engine manufacturers. Yes, and what we see as a long impact, as I said before, we want or we hope that one day the plant that is developed in our project will be deployed in several locations in EU. And also quite important in the project because the focus is not only on technology but also on human beings and stakeholders. We are quite happy to announce that we have a very large board of advisory members that support our projects, that provide feedback. So a board consisting of members not only from EU country, but also just know that we have the Port of Singapore as an important partner providing feedback. And another important result is that we put in place 2 communities in practice in Spain, in Greece. So here you can see pictures of a meeting that took place in Valencia with a lot of stakeholders. So what we try to do is involving them in some activities, trying to co-create some results with them, because we know that if we want that the results we develop turns into concrete projects, we need their support. So I would like to thank our 2 COP managers, the 2 ports of Valencia and Thessaloniki, for, let's say, their efficient coordination in managing the communities of practice so far. And we have a lot of activities planned with them in the next weeks. Yes, so this was a very short introduction about our projects. I'd like also to thank my colleague Natalia Ranovic, who supported the organization of this webinar. And if you have additional question, feel free to send us an email, either to our coordinator, to myself. And you're also invited to have a look at our project webpage and LinkedIn accounts. Thanks a lot.
Thank you. Thank you very much, Paul, for this very interesting presentation. And we have 2 questions for you from Kostis. And I will read them from our question and answer box. The first one is it possible to know the type of catalyst for the methanol production?
Oh, I think this is maybe a question that Katja, our expert, could ask, but I'm not in the, let's say, in the very details of our technologies.
Yes, so hello from my side. The catalyst is a standard commercial catalyst, methanol synthesis catalyst, copper zinc. I think so, yeah. But commercial one.
Thank you, Katja. And we have a second question, again, for the Poseidon project partners. always by Kostis, which is about in emerging economies such as China, there are thoughts to extensively upscale e-methanol production. Do you have insights from China, US, or other economies on their TRL levels and upscale? For example, through a market analysis, depending on the stage of the Poseidon project?
So we definitely plan to have some market analysis, but this will start a bit later in the project. So I cannot share much information about this now. But we will probably organize either some webinars, workshops in the futures about this aspect, because it's also important. Or what we can just tell what we plan to do in our project. We plan to map, let's say, the location where an implementation of e-methanol plants could make sense in the futures. So based on the feedstock availability and also on the end user demand. This will definitely be done. And regarding China, we are connected, as I said before, with the Asian continent through the port of Singapore. So we'll also investigate what they do when we will do our benchmark.
Thank you, Paul. And you have also a question from the chat. Diana Powers asks you, is your e-methanol process similar to that used by HIF in Patagonia, Chile?
So I'm not, to be fully honest, I'm not aware of this other process. I don't know if Katja is, but we can have a look.
Sorry, my video won't start. Okay. I'm not really sure if the HIF process is from CO2 or CO, but our process is a combined process, so it absorbs the CO2 directly from the biogas. We don't need to separate the CO2 from methane before we go in our process. So this is definitely not used by anybody else. And so the process at Punta Arenas is a different one.
Thank you, Katja. And I think that we are arriving at the end of this first part of the webinar, which has seen the presentations from 3 very interesting and ambitious projects, which share some aspects and are also very different in some other strategies. And we can start now with our next session, which is a panel discussion, which will indeed try to underline synergies and specificities of these 3 projects. And we'll cover a series of themes that we will be highlighting with my questions. And so I encourage Galina and Kostis to come back on stage. And I also welcome the 2 other panelists of today, Katja Haas-Santo and Maria Georgiadou. I will briefly present them. Katja currently works for the Karlsruhe Institute of Technologies, which is one of the project partners of the Poseidon project, where she is Deputy Director of the Institute of Microprocess Engineering and coordinates several projects in the field of Power-to-X. She studies chemistry at the University of Karlsruhe with a focus on technical chemistry and reaction engineering, and she has a PhD in the field of heterogeneous catalysis and the reaction engineering at the University of Stuttgart. And finally, we have with us Maria Georgiadou, who is a senior expert in the Directorate General for Research and Innovation at the European Commission. She steers the strategic orientation for research and innovation in renewable fuels, biofuels, and bioenergy, and the implementation and development of research and innovation projects, programs, and policies under the European Union's framework programs. Maria holds a PhD and master's degrees in chemical engineering at the University of Illinois in USA, and a Master in Business Administration and Integrated Master in Chemical Engineering at the Aristotle University of Thessaloniki in Greece. So welcome both on stage. And without further hesitation, I would like to start with the first question. And by the way, I also saw a question asked by Eleni Liakakou on the chat, was also answered in writing directed and answered in writing by Galina, but it will also the topic of it will also be touched in our panel discussion. So I will start with the first question for the panelists, and we have seen it's about the engagement of stakeholders along the project's value chain, which is one of the major factors that will determine the success of this project, and indeed is about effectively involving the stakeholders in the different steps of the value chain, from feedstock suppliers to end users. So I would like to ask to the project representatives, which are the methodologies that your projects adopt for an effective engagement of stakeholders in your project? And I would maybe start with Katja from the Poseidon project. And you're muted, Katja.
Sorry, I think Paul already told a little bit about our communities of practice. So in both ports, like in Valencia and Thessaloniki, we like to establish a local community of practice. So local partners who are established there and part of our advisory board, and they, at the case study level, they, for each port involved, they work together, and so it strengthens the collaboration locally, and include the value chains directly, locally, and provide inputs also directly from this community in terms of the needs, the expectations, and maybe like feedstock chain capabilities, what they want, the end users. So we go directly locally. I think this strengthens this outreach quite well.
Thank you, Katja. Galina, would you like to contribute to this from the side of Butterfly?
Yes, sure. I would say that we primarily engage with the stakeholders in work package 4, 5, and 6. So 4, 5 I already presented today. It's all about value chain and strategy towards exploitation. So basically we organize regular meetings or work sessions where we work together with industrial partners and research organizations who develop models for value chain optimization. So we sit together and we look at their businesses, like where primarily their business is located. We look around what is their valuable feedstock, how they could utilize, if they already have any partners. If it's closed, quite often it's close to harbor, for example, because they already have some certain networks. So we start working out with what is already available, plus the research organization bring in the broader picture and say, hey, but would you like to look in other regions as well? Because here it could be very promising for you to set up a plant as well. That's the first thing. It's quite insightful because everyone has different knowledge, of course. Someone has business intelligence, some has policy intelligence. So everything comes in place because regulations, of course, play also a huge role. And the work package 6 is dedicated to dissemination. So we organize regular events. We participate in such joint, of course, webinars and in conferences. So I think that also increases our visibility and engage stakeholders that are not yet present in the projects as partners. So that would be my answer, I guess.
Thank you, Galina. And Kostis?
Yeah, and before answer to that first question, I would like to mention that in FUELPHORIA we're working on the development of 9 value chains as a combination of different process steps that result from these 4 demos that I described earlier. From these value chains, the total number of value chain actors and stakeholders participated in business models co-design is target to be at around 100. This is something indicative of how critical aspect for our project impact maximization is the effective engagement of the stakeholders. So trying to reply to your questions, the methodology that we are adopting are, first of all, that what is also expected and is also adopted in all typical EU funded project, which is the setup of advisory board with relevant stakeholders from from the different fields. So far, we have already 5 stakeholders confirmed they participate at advisory board. Also, we have foreseen clustering activities at the later stage of the project, like workshop, events, etc. And something what we have done so far is in order to elicit the stakeholders' market needs, we have conducted 24 interviews aiming to reveal issues that could favor or hamper the updates of our technology solutions. Indicatively, we have reached 10 stakeholders from technology providers, 5 from the distribution part, and 4 from end users, and 5 suppliers. And last but not least, very important, is that within the project we foreseen to develop a marketing toolkit for new value chains development that will be used to reach out to interested stakeholders, to create potential synergies, to present part of the project's aims to potential investors, and explain in a user-friendly way to policymakers and the research community the results and the impact of our project.
Thank you, Kostis. And these are very innovative and very interesting approaches, which look at possible replication and investigation and the nudging of different interests and different capabilities of the various stakeholders. And these answers make me turn to Maria Georgiadou from the European Commission, and I would like to ask her at the on the same topic, if there are any tools or mechanisms that the European Commission can provide to assist local stakeholders in this engagement in these engagement processes.
Thank you very much for inviting me, first of all, to this webinar, where I am also informed about these valuable projects that stem from our research and innovation program topics, and we're fully supportive to such type of projects. Now, the answer to your question, we have plenty stakeholder platforms and forums in place. I can just mention a few. One is the European Technology and Innovation Platform Bioenergy, which actually brings stakeholders from the feedstock to the end use, technology developers and policymakers on board to discuss issues about what we here listen about complete value chains in the area of biofuels, advanced biofuels. Then we have the working implementation group of renewable energies and on renewable fuels and bioenergy under the SET plan, which actually involves on top member states. So it brings this into the attention of national authorities, not only, but also research, academia, industry, and these groups work together, the TIP Bioenergy and the AWG on renewable fuels and bioenergy. And on top of that, there are external forums like the RLCA Alliance, the Renewable Low Carbon Fuels, Renewable and Low Carbon Fuels Alliance, which is a big alliance bringing together stakeholders for the production and the use of this type of fuels. So yes, there are instruments. We think that there is a need for further dialogue in this area around the value chain. So we're thinking of supporting in the future this dialogue to involve all real actors at one forum. And that will be farmers, that will be technology developers, the researchers, academia, citizens, national authorities, end users from all types of sectors that will use these products. So to come together and talk about even those that are active in climate and NGOs to come and talk together about what is necessary to do, what measures need to be there in order to really boost implementation of complete value chains in advanced biofuels. That's in short. I don't think I covered everything that we are doing, but at least I gave you some essential elements.
Definitely, this was a very encouraging, I would say, answer, because it's very. I'm very pleased to hear that the European Commission provides these tools and platforms to facilitate and encourage cooperation, and also is in favor and not only theoretically but also practically of further dialogue and structured cooperation along the value chains, which is indeed a key factor of success for the projects that. Like the three that we are.
And participation in these platforms is free of charge. These it is important to know that these are not associations. They are platforms that they are interlocutors with the European Commission, so it's free of charge.
Thank you, Maria. And I would like to move to the next question, which focuses on another type of challenge that the projects might face or will face, which is related to the upscale in the production of the biofuels and renewable fuels, which is also in line with one of the questions that was asked in the question and answer box. So. We know that biofuels are large-scale commodities, and successful technologies demand high amounts of feedstock to scale up their production. So my first question on this is directed to Galina of the Butterfly project, and is about the strategies that your project envisages to develop a biofuel production at an industrial scale, given the limited availability of biomasses.
Yeah, this question already came up in the chat, indeed. I think this question is actually reoccurring. So we all don't know what is the real biomass availability. So, and of course, it very much depends on the region of the country. If we only focus on Europe, yeah, it's one thing, of course, globally it's different. But I would like to highlight that our focus is on the low-grade feedstock. So the feedstock that doesn't have competitive use. So it cannot be used for food, or I don't know, as fertilizer. So maybe I'm not that much of an expert, but basically a sewage sludge, right? So we would like to assess the volumes of these residues. And therefore, we said, okay, if we want to have it decentralized, then we need to opt for somewhat small to medium sizes, because the availability of the feedstock will be driving. And we already see that we can, in certain regions, we can easily set up several, about 100 megawatts plants, and in other regions, that would be a smaller scale. So it's pretty much depends. In urban area, of course, there are plenty of municipal solid wastes. So in that sense, we are quite realistic. Of course, we set an ambitious target and we strive for that. But in fact, we actually don't know how much will be possible in 2050. Those are our projections based on the information we could collect during our assessments. And of course, the market will be driving. So we cannot produce more renewable DME that it will be required. And the market will change with time. So maybe now it's small, and once we start replacing the fossil fuels, it will also grow. So it's very dynamic system, and we work with current data and with the projections. So let's see how it goes.
Very, very good. And a similar question I will ask to Kostis and Katja, more related to the limited availability of green hydrogen. What strategy can be put in place by your project on your side to overcome this barrier? And also, what role can the logistics aspect play in the upscaling of technologies developed in your project? And I see Kostis, please.
Okay, thank you, Piero, for the questions. Yes, it's a common sense that the hydrogen cost has the lion's share on the e-fuel production, and its high cost is the main barrier that prevents us from the further upscaling. Our clustering activities and policy recommendations will put this matter in top of the agenda of the relevant activities. And in parallel, we also investigated various processes for the production of synthetic fuels, renewable, as we say, RFNBOs, such as the synthetic methane, paraffinic hydrocarbons, and for maritime and aviation, methanol and ethanol. And the economic viability of these value chains will trigger the stakeholders to seek for green hydrogen at a lower cost, at the capacity that makes this investment economically attractive.
Thank you, Kostis. Katja?
Yes, so as we rely on CO2 sources which are locally produced, like from wastewater treatment plants or industrial plants like a lime plant, we are not in consequence with food and things like that. So this is from the CO2 source, and I think the wastewater treatment sludge will be there, as well as lime plant and these industrial sources we will have also in the future. These are inevitable. And our concept is more on a decentralized production. So the production of the hydrogen can be done with a renewable power generated directly attached to these plants. And yes, for sure, we have to look where it is possible. So in case we see for Valencia and Thessaloniki, we have good PV possibilities as well as wind, where we can use the power for these plants. And all in all, the use cases at the end of the project will see how far we can upscale in size of also numbering up the sites.
That definitely makes sense. And following these takes from the various projects, I would like to ask Maria from the European Commission for a comment, and also contextually ask her how can, in general, public authorities at different levels support stakeholders to facilitate the large-scale biofuels and renewables fuel production?
Okay, first, I would like to say that biomass is not limited, biomass Annex 9 based, to just put the things in the right basis, because we did a study and we found that Annex 9 based biomass at the EU level, associated countries and UK, is available for all energy uses. And you can find the numbers in the study that the DGRPD has published recently on the development of outlook for building industrial capacity for advanced biofuels. Now, in the question of how public authorities can help, first of all, the European Commission is, let's say, an EU level administration that helps with programs and other instruments, the development, among others, of value chains for value chains for advanced biofuels. Now, public authorities could be involved into these projects, and I saw that in one case there is a public authority, which is the Swedish Maritime Administration, if I'm not mistaken. So I think in one of the projects, we have other projects in which public authorities are involved. So public authorities can be like the drivers, either using the product that these plants or pilot or whatever produce, or even supporting in their policies the uptake of this type of products, like in the missions cities. All the greening is actually in the cities supported. And I think also something as a strategy that could work is to do what we call renewable energy valleys. What is that? It is local and decentralized hubs where you can have the production of renewable electricity or renewable heat together with renewable fuels. So all these limitations in terms of hydrogen and renewable electricity somehow to be attacked at local level. Now, in terms of local biomass, which sometimes is not very much available, one can think of bioenergy hubs all over Europe, where these will be like intermediate bioenergy carriers hubs, where you collect and densify the biomass, and then it is easier to move these dense carriers to longer locations and use them outside the local collection area. So I think this could be put in place at an EU level as a strategy. We had a topic under Horizon Europe in the last call, I think. We fund also 2 projects on renewable energy valleys and see how this concept can be further flourish in order to overcome this type of barriers. For CO2, yes, this CO2, unless there is DAC, direct air capture, in place that can provide ambient CO2, at what cost we tell me, okay, with the limitations of renewable electricity, etc., then the CO2 will be anyway limited, as from the biogenic resources or from the power sources in the chemical industry will not be eligible after 2041, etc. So we are thinking of doing this in terms of strategic approach for solving the deployment of complete value chains.
Thank you, Maria, for this for your answer. And at this point, I would like to ask to the project representatives if you have any feedback on your side on the take that Maria just provided, and also if in relation to possible recommendation. We know that the projects are only at their first year, but with the relation to the answer that Maria just provided, do you have any feedback or any recommendation on the possible tools, again, that could support the facilitation of the scale-up phase? Galina, please.
I would like to mention 2 aspects. So we are all, I think, familiar with the death valley of technologies. So normally it's a demonstration phase. So I would like to raise attention that the demos often require permits. And apparently getting a permit is a very difficult regulatory step. So if it could be simplified or aligned between different countries, because for us, for example, we will be moving the pilot from the Netherlands to France, where the regulations differ. So I see that it takes a lot of time and the project has really limited time. So that could help the actions in that respect. And the second issue that I already see is indeed it's related to availability of the feedstock. So how to increase the utilization of the feedstocks? One of the strategy is to mix them. So use mixed feedstocks. And when you start mixing, for example, municipal solid waste and prunings, you run into regulatory aspects as how it's qualified. Is it biological, not renewable fuels of non-biological origin? Is it recycled carbon? So carbon credits sometimes can be complicated. So I think it would be nice to clarify how this allocation is done when you mix different feedstocks? Because it can be quite a dynamic system based on seasonality as well.
Thank you, Galina. Maria, would you like to quickly
I can
respond to
quickly
this?
answer to Galina that yes, permitting is an issue, but Commission has worked towards this problem, and I would like to tell you to take a look at the Commission recommendation that was announced on the 13th May of 2024. The number is 1343. And this is about speeding up permit granting procedures for renewable energy and related infrastructure projects. And then you see whether you will find answers to this challenge, how to speed up the permitting. And the other question on mixing feedstocks, okay, we have actually with RNI enabled a large portfolio of technologies, and this is to use different feedstocks. So one way is to use the feedstocks that are appropriate with the technology that is appropriate for converting these feedstocks. Now, if you mix different type of feedstocks, then you need to somehow account for the biogenic carbon into the end product, and then declare only this part as the one which is eligible under the RED regulation and the other legislation in the Fit for 55. This, for example, is done for the co-processing in refineries where they use carbon-14 in order to identify the biogenic carbon in the final product, because they co-process bio and non-bio fossil type of feedstocks in the refinery. So yes, there are ways about it, and I think there are solutions and answers.
Thank you, Maria. We are already running slightly over time, but I would like to take the last two questions from the audience. The first one is from Leonidas Kanonis, who asked to Maria the following question. Annex 9 feedstocks are indeed abundant and should be used more and more. The problem is that regulation like RefuelEU Aviation are adopted without proper impact assessments on waste feedstock availability, nor in connection with other regulation like FuelEU Maritime. A more realistic approach on regulation is needed to provide more industry certainty and reduce investment uncertainty. Is this issue known within the European Commission?
As an answer to Leonidas, yes, services collaborate when they propose legislation in the various sectors. For example, FuelEU and FuelEU is transport, RED 3 is energy. But I don't really think that there is so much incompatibility, because in RefuelEU we have as SAF the biological, the non-biological, and the recycled fuels that contribute. So here we are talking about renewable fuels. The RefuelEU added also non-renewable fuels into this. I don't see where is the incompatibility in terms of what we are discussing here in taking up, scaling up the complete value chains of advanced biofuels. And FuelEU Maritime has also types of fuels, but mainly is based on biofuels, biogases, and RFNBOs to deliver, like the methanol here, to deliver the targets on the decreasing the greenhouse gas intensity in the energy supply to transport. So really, I don't agree with Leonidas in terms of market distortion, as he wants to put it. But the other thing is that these regulations are revised every now and then. And I think every 2 years they open for following up to see whether they are delivering what they should be delivered, whether they are on the right track, and then things can be corrected or revised according to the needs of of the market.
Thank you, Maria, for your answer. And I would like to close with the last question that comes from the audience, especially from Daniele Wilson, who asks, where is the space for Africa in this innovation? And I would like to ask this question specifically to Kostis, as we have in FUELPHORIA a collaboration between the European partners and also African stakeholders.
Yeah, thanks. We are considering two countries, one from the sub-Saharan region, which is Kenya, and the second is Egypt, which is for the Northern Africa. And these two countries have different capacity and potential in terms of renewable energy and feedstock availability. And the idea is to, based on the portfolio of the value chains that we are investigating in the project, to see what is the replicability potential of the most suitable of these technologies to be applied in these two countries, given the situation and the status regarding the potential, the feedstock potential.
Thank you, Kostis. And on this last answer, which provided a broader view also outside of our European context, I would like to come to an end of this webinar. We are already 5 minutes later than our allocated time, but I think that this very interesting presentation and these very knowledgeable speakers could deserve to delay your lunch time of a couple of minutes. So I would like to thank you so much, the speakers and all the panelists for their very insightful presentation and lively discussion. And I would like to thank you, the audience, for your question and your participation today in this online event. I would like to remind you of to follow the projects FUELPHORIA, POSEIDON, and BUTTERFLY on their online channels, website, and social media, LinkedIn especially. And I remind you that all participants will receive the slides of the speakers and the registration of today's webinar. We are at the end of today's webinar, and again, I thank you very much for your attention. See you at the next jointly organized webinar by FUELPHORIA, POSEIDON, and BUTTERFLY. And I wish you a very great afternoon. Bye-bye.
Thank you very much.
Bye-bye. Thank you.
Bye-bye.
Thank you very much. Bye-bye.
Thank you for sharing, Piero. Have a good day, everyone. And meanwhile, I will find a way how to leave it.